So let's get started with another part 2 without dragging much further. Okay. So now we are gonna discuss about reversible and non-reversible reactions. Unless until we become so clear about these two topics, we can't move ahead. So for that, let us take a daily life example. What example shall we take? Take an ice cube, which is actually a solid. It is at freezing temperature. Definitely, it will be solid. Now, what makes this ice convert from this solid to this liquid when put at room temperature? Yeah, what makes it? Definitely temperature change, right? When they change in temperature, because from freezing temperature to room temperature, what actually happens? Ice melts. You all know this phenomena. Don't have to tell separately, right? Now, here, why do we call this particular reaction as reversible reaction? Because once the ice is solid, if you bring a ice cube into room temperature, it will definitely melt and become liquid. Once it is completely liquid, again take that liquid water and put it in ice, put it in this freezing temperature. What actually happens? Yes, it will convert again into solid, that is nothing but ice. So this type of reaction can be reversible reaction, solid converting into liquid, liquid into solid. This is the best day-to-day life example which we can have. So this is reversible reaction. And guys, just remember, whenever we are talking about equilibrium, we'll be always speaking about reversible reactions only. We don't consider non-reversible reactions or irreversible reactions. Let us take a quick example of non-reversible reaction. What is this non-reversible reaction? It is something which cannot be reversed. For example, take wood, combustion, oxidation. Once the wood is burnt, right? What are the byproducts and products produced? Carbon dioxide is produced, right? So from this carbon dioxide and heat and light, which are the products of this particular reaction, you can never get your wood back, right? Because you have burned it. So this is a non-reversible reaction because it is really impossible to get your products back, get your reactants back from the products. What is the reactant in this case? Reactant is wood. What is product in this case? Product is, yes, product is carbon dioxide, heat, light, water, etc. So, once you're clear with these two topics, let us move on to equilibrium. So, all only reversible reactions can be in equilibrium. So, why are we talking about equilibrium? What is the importance? We will see in next module. In this module, we'll only be clear about what is it, right? We won't see why is it, we'll see what is it. Since this is the first time you people are studying equilibrium, we will actually take up a nice example to get into the topic. You will be taking a beaker, right? Bunsen burner. Here you're taking Bunsen burner just because you want the temperature to actually stay in your control, right? Yeah. So you will be sealing this beaker completely. This is sealed, right? Now what am I trying to tell you? Just before sealing it, fill it some with water. When you So, yeah, temperature inside the flask should be constant. Once the beaker or flask has reached a certain temperature, just take off the heat, right? So, the temperature inside the flask is constant and there is no heat exchange between flask and out environment. This is called thermoflask because it can actually maintain the temperature or heat inside flask constant. So yeah, what I'm trying to tell you is once the water has reached in constant temperature, what it will be doing? Yeah, you know, water has the tendency to change into water vapor, that is vapor, right? Once the water evaporates up like this, what happens? The vapors go up in the air, they come here, they accumulate in this area. Like what extent the water will get evaporated or vaporized? Some limit should be there. Once the limit is reached, what will happen? So imagine that enough vapor is collected in this area. What will happen if this continues to be? The flask will break. But that is not happening, right? In this case, something else is happening. When you see the flask from out edge, what will you able to see? You'll be able to see that no reaction is taking place at overall level. But this is not right. Reaction is occurring at molecular level. But why are we able to judge that no reaction is actually happening at eye level? What is actually happening inside the flask? So let us see. This is very important concept which you have already studied in class third. Yes, don't laugh. It's class third concept which you are actually advanced advancing it into concept called equilibrium. You guys have already studied this. But thing is that actually if you once understand the concept, it's really very easy for you to understand all the other concepts like equilibrium constant, kcq, reactant, reaction coefficient. I don't want to tell all those terms to you and make you afraid right now. So what actually is happening here is all the vapor is collected in this place, right? Once it has reached the maximum content, maximum concentration, what will happen? The vapor also have tendency to change into water. What is this process called? Yes, you're right, this is nothing but condensation. Water to vapor, vaporization. Vaporization, yes. So what will happen? This process actually go on at molecular level. Vapor will get condensed into water, and water will be vaporized into vapor. So this is what actually is going on inside the flask. Hope you understood, right? So it's so simple as that. This is the third class concept which you're applying here, right? So once the concentration of the vapor becomes more, it will get condensed into water. Once the concentration of water gets more, reaches maximum level, it gets converted into vapor. This is what actually happening inside the flask. So these two reactions, forward reaction and the backward reaction, are occurring simultaneously. Yes, simultaneously, and the rate of forward reaction and the rate of backward reaction are same. Only at that case it will attain equilibrium. So there are few conditions for equilibrium. What are those? Yes, let me write down clearly. So, the rate of forward reaction and the rate of backward reaction are equal and occur simultaneously. In this case, what is forward reaction and what is backward reaction? See, backward reaction can be anything, forward reaction can be anything. See, in this case, vapor is converted into water by the process of condensation. Here, I said you before that we are going to study how, we are not going to study why. So, condensation, either it is because of condensation, either it is because of evaporation or vaporization, you just don't have to care about it. Just vapor is getting converted into water, and water in turn is getting converted into vapor. So this process, backward forward reaction, backward reaction, actually you have to write it in this way. So we'll be using this term so many times in this chapter. This is the thing to actually represent equilibrium state. And yes, that is the reason I said it only occurs in reversible reaction. There are many reversible reactions, guys. It's only not a, water, ice, liquid, gas. There are a number of reactions. So let's meet in another video to continue my chapter. So thank you so much for watching. Please like, subscribe and share my videos, and if you like, please do comment, and if anything has to be improved, please let me know, right? And this is about all about equilibrium. We will be studying about equilibrium constant and many more things. It's quite interesting and very easy chapter. Please don't ignore it. You can score hell of marks in this chapter, right? And thank you once again. Bye bye, guys.